The Galactic Engineering Symposium was held every 10 years on Station Valorum Prime, a structure so precisely engineered that its central atrium maintained a gravitational constant accurate to 37 decimal places. Tessyn of the Kelvani conclave had attended every symposium for the past 2 centuries. She had chaired the last 4. She had never once needed to touch a wall to determine if it was plumb. She could tell from across the room. This year's symposium was, by every measurable standard, the most prestigious in its history. 400 engineers from 200 species, 17 unsolved problems in the gallery, 17 monuments to the limits of galactic knowledge, each one carefully curated, each one representing decades of collective genius brought to a respectful standstill. Tessyn had selected them herself. She had not selected the human. The human had arrived on a courtesy provision buried in the Multi-Species Participation Accord, a document Tessyn had co-authored 40 years ago without ever imagining anyone would invoke its Section 7, Paragraph 12, Clause 4, which required all registered spacefaring civilizations to receive an invitation, regardless of their current level of technical development. Humans had been spacefaring for 53 years. Their engineering, as Tessyn had reviewed it, was functional in the way that a rock tied to a stick was functional. It addressed problems. It did not elegantly solve them. She had assigned the human a booth in the Eastern Annex. The Eastern Annex was traditionally reserved for cultural exhibits, artisanal metalwork, historical demonstrations, things that were interesting without being relevant. She had been, she believed, generous. The booth display, when she passed it on her inspection round, made her primary optical sensor twitch. 3 strips of a fabric adhesive material she didn't recognize, a cylindrical canister of something called WD-40, the label of which described it as a penetrating oil, lubricant, moisture displacer, and cleaner, which was either the most versatile substance in the galaxy or a sign that humans couldn't make up their minds about chemistry. A hammer, a hand-lettered sign that read, in standard trade script, Human Maintenance Solutions, with a small drawing of a wrench in the corner. No theoretical framework, no published papers, no awards displayed, though humans had been to space long enough to have some. Tessyn's primary optical sensor produced its involuntary twitch again, the one the Kelvani medical literature called the flinch, the one she hadn't produced in 40 years, the one that happened only when her theoretical architecture encountered something it could not classify. She moved on. She had a symposium to run. The human sat in his booth for an hour. Tessyn noted from a distance that no one visited. He was a large creature, soft-shelled species, bipedal, with broad hands and a weathered face, and a canvas bag that he kept rearranging. He wore a maintenance jumpsuit, dark blue, with a name stitched on the chest in the standard colony fleet format. Patterson. He looked at the symposium's other exhibits with the mild, unhurried interest of a man at a museum who'd been to better museums. Not dismissive, just not impressed. At approximately the 90-minute mark, he stood up, slung his canvas bag over his shoulder, and wandered away from his booth toward the Unsolved Problems Gallery. Tessyn's triangular optical cluster registered the direction of his movement and noted it as a mild concern to follow up on. She was mid-conversation with the Growlac fabricator about the self-repairing alloy problem and chose not to interrupt herself. Later, she would categorize this as an error in judgment. Later still, she would understand that no action she could have taken would have changed what happened next. The only variable she'd miscalculated was the human. The Unsolved Problems Gallery occupied the symposium's central exhibition space, a long hall designed to convey scale and gravitas. 17 stations lined the walls and floor, each one a monument of documentation, holographic models, technical schematics, published paper archives, interactive simulations. Engineers had clustered around their favorite problems like pilgrims at sacred sites, conducting ongoing debates in the particular vocabulary of their disciplines. Tessyn had heard the same arguments for years. They were sophisticated arguments. They were going nowhere. The human walked through slowly. He didn't read the technical documentation. Tessyn, when she eventually reviewed the station logs, noted that he spent approximately 3 seconds at each one. He read only the simplified description panels written for non-specialist visitors. He looked at the holographic models without apparent comprehension. He touched several of the display cases, not the devices, the cases, the glass. He knocked on it once at Station 3, listened to the sound, and moved on. He stopped at Station 1. The quantum coherence stabilizer had been Dr. Prelith's problem for 12 years. It was, by common agreement, the gallery's most beautiful failure. A device that achieved genuine quantum coherence, holding a perfect energy state, for exactly 4.7 seconds, before collapsing into decoherence. The mechanism of collapse was an unexplained vibration. 600 published papers had addressed it. The consensus, reached after exhaustive analysis, was that the vibration arose from quantum boundary interactions at the field's edge, a decoherence cascade that was, at some fundamental level, inevitable. The device was solving the unsolvable. It just couldn't do it for longer than 4.7 seconds. The human watched the demonstration cycle 3 times. He tilted his head to the left. He placed his open hand against the side of the device housing and held it there. Then he said, to no one in particular, in a voice carrying the same tone a person might use to observe that it was slightly chilly, "That's a mounting problem." Tessyn was not close enough to hear this. Dr. Prelith was. Dr. Prelith was a Thesari. Bioluminescent patterns across her thoracic plates, 6 jointed limbs, the quiet precision of a mind that had spent 12 years inside a single problem. She approached the human with the careful patience of an expert addressing a layperson. She explained, concisely, that the vibration was quantum in origin, a decoherence cascade, field boundary interactions. The mounting system was precision engineered to nanometer tolerance. It could not be a mounting problem, because the mounting system was perfect. The human nodded politely. He said, "Can I look at the mounts?" Prelith, with the generosity of a scientist confident in her own conclusions, said yes. The human crouched. He went below the device, not examining the holographic display, not reviewing the documentation, just looking at the physical thing with his eyes and, after a moment, with his fingers. He touched each mounting bracket in sequence. On the 3rd, he paused. He reached into his bag and produced a flashlight, a device so archaic that Tessyn, later reviewing the gallery security footage, had to look it up. A portable illumination tool, powered by chemical reaction, used by humans for approximately 3 centuries because they apparently couldn't be bothered to install fixed lighting in whatever spaces they needed to see into. He shone it at the contact point between the 3rd bracket and the housing. He said, "This bracket's got a burr." Prelith's bioluminescence flickered. She explained that this was impossible. The brackets were manufactured to molecular precision. The specifications were verified by 3 independent certification bodies. The human showed her. The flashlight's beam fell on a microscopic irregularity at the contact surface, not a manufacturing defect. A stress fracture. Thermal cycling over 12 years had expanded and contracted the bracket material in cycles too small for standard monitoring to detect, and the repetition had produced a hairline imperfection. Not quantum, not theoretical, a physical flaw in a physical part, producing a physical vibration that had been misidentified as a quantum phenomenon because everyone who looked at the problem was looking at the field, not the housing. The human opened his bag and removed a small file. He also removed what Tessyn would later learn was called duct tape, specifically a vibration-dampening variant, though the base material was the same fabric adhesive strip she'd seen at his booth. He filed the burr smooth. He applied a strip of tape to the contact surface. He remounted the bracket. He powered the device on. The coherence field stabilized. 4.7 seconds passed. The field held. 10 seconds. 30. 1 minute. The demonstration counter, which had never passed 4.7 seconds in 12 years, climbed past 2 minutes and was still climbing when Dr. Preleth's bioluminescence went completely dark. The gallery fell quiet around Station 1. The counter reached 5 minutes. The field held. Preleth's lights came back on at a frequency Tessyn's translator rendered as a sustained low-register vocalization. The intellectual recalibration tone, familiar from a Thesauri's first exposure to a paradigm-breaking result. From 3 stations away, Tessyn's primary optical sensor flinched. She told herself it was dust. Word travels at approximately the speed of the interesting. By the time the human reached Station 2, the self-repairing hull alloy that repaired everything except its own internal fractures, he had an audience of 40 engineers trailing him at a respectful distance. By Station 3, it was 90. By Station 5, it was 200, and engineers were climbing on display risers to see over the crowd. At Station 2, Master Fabricator Gorin of the Growlac took personal offense. The self-repairing alloy was his work. 7 years of metallurgical research. A material that healed external damage in real time through molecular reorganization, but developed internal microfractures that accumulated over time and eventually compromised its structural integrity. The Growlac were a heavy-gravity species built at roughly the scale of a cargo container, and Gorin had the temperament of a man whose life's best work had a fatal flaw he couldn't find. He stood with his upper limbs crossed, watching the human examine a test sample. The human flexed the alloy sample, tapped it with his hammer, held it up to the light, tapped it again, and listened to the tone with the focused attention of a musician tuning an instrument. He said, "It's healing too fast. The repair bonds are forming before the stress has fully distributed, so it's locking in the fracture pattern instead of letting the material rest. You need to slow the repair rate, cool it down during the healing cycle, give the stress time to move through the material before it sets." Gorin uncrossed his upper limbs very slowly. He said, "That's absurdly simple." The human said, "Yeah." Gorin stood for a moment, then turned and instructed his team to run the test. 3 minutes later, the alloy sample, cooled during its repair cycle, healed without fracture for the first time in 7 years. Gorin let out a sound that shook the gallery's decorative panels, a Growlac boom of genuine delight. He then did something that surprised everyone, including the human. He reached down and picked the human up in both arms, lifting him approximately a meter off the ground in an embrace that the human received with the equanimity of someone who'd been unexpectedly hugged by a freight vehicle before. Tessyn flinched twice in quick succession and walked faster. Station 3, a navigation algorithm that produced errors at high computational loads. The human watched the demonstration, ignored the holographic model of the algorithm's architecture, and instead looked at the processing unit housing. He pointed at it and said, "Your computer's too hot. Hot computers make mistakes." He produced the WD-40 canister, applied a cooling variant to the heatsink contacts, and rerouted the thermal exhaust with a bracket adjustment. Computational errors? 0. Station 4. A water filtration membrane degrading after 10,000 cycles. The human looked at the housing geometry, identified that the inlet valve was creating turbulence that eroded the membrane edge, adjusted the valve with a wrench, added a zip tie as a flow restrictor. Zip ties being small plastic fasteners that Tessyn's aide later described charitably as structural improvisation devices, and the membrane's degradation ceased entirely. Station 5. An energy conduit losing 12% efficiency over 100 meters. The human traced the conduit path, found 3 unnecessary bends that had been installed for aesthetic reasons by the Velinori design team, straightened them, and watched the efficiency loss drop to 3%. He examined the curves with a brief expression of appreciation before dismantling them and said, "Pretty though." Tessyn stood at the gallery railing. Her aide had suggested medical attention after the 3rd flinch. She had declined. By the 5th, her plating had shifted into a configuration that her species literature classified as significant structural concern. She could feel the misalignment and the harmonic resonance of her digits. She was not in distress. She was in something worse. The state of a theoretical physicist watching the universe decline to follow her equations. At Station 6, the crowd had become an entity. 500 engineers from every major galactic species occupied every available surface in the gallery, on risers, in doorways, perched on display cases. Some were hostile. Decades of published work reduced to a zip tie and a wrench was not a comfortable experience. A team of Cathari engineers had been arguing quietly among themselves since Station 3, their clicking dialogue carrying the cadence of people trying to decide whether to be angry or fascinated. A Marathi engineer, whose silicon-based neural architecture was poorly suited to processing events outside established probability distributions, had entered a diagnostic loop and was standing motionless near the exit, running the same calculation repeatedly with no output. The human was oblivious to all of it. He moved through the gallery with the unhurried attention of someone engaged in a problem they find genuinely interesting, not a performance they're giving for an audience. He stopped at each station the same way, looked at it, touched it, listened to it, occasionally smelled it, though Tessyn's translator had trouble conveying what olfactory data he was collecting. He asked brief, non-theoretical questions of the nearby researchers. He never asked how something worked. He always asked what it was supposed to do and what was stopping it. The crowd parted around him as he moved. Tessyn, watching from the railing, recognized the shape of what was happening before she could name it. A shift in center of gravity. The symposium had a new center, and it was a maintenance officer in a grease-stained jumpsuit with a canvas bag of human tools. Station 11 was the symposium's most famous problem. The harmonic resonance engine had been unsolved for 17 years. The concept was elegant. A drive system that achieved propulsion through controlled resonance, using the engine's own harmonic output as its fuel source. The mathematics were impeccable. Every simulation confirmed it. But in physical testing, the engine produced a catastrophic vibration that built exponentially within minutes, a standing wave that tore the housing apart before the drive could be used. 42 published theoretical models addressed the discrepancy between simulation and physical reality. None of them agreed. None of them worked. The gallery fell quiet when the human reached Station 11. Not gradually, suddenly. 500 engineers recognizing collectively that something significant was arriving at something significant. The human stood in front of the engine for a long time. He walked around it once, then again. He put his hand on the housing in 7 different places: upper casing, mid-frame, 3 points along the lower section, the mounting ring, the exhaust port housing. He crouched. He stood. He tilted his head. Then he opened his bag. The murmur that went through 500 engineers at the sight of the hammer was the most complicated sound Tessyn had ever heard in 40 years of symposiums. It contained disbelief, protest, anticipation, anxiety, and a thread of something she could only classify as hope, irrational, unearned, and apparently universal. She took 1 step forward from the railing, stopped herself, did not flinch, focused. The human studied the engine housing for 30 seconds with the stillness of a man who was very good at listening to machines. He positioned himself at a specific location on the lower casing, the 3rd vibration point he'd touched during his walk-around. He raised the hammer. He struck. 1 blow, precise, targeted, unhurried. The engine's vibration changed. The catastrophic oscillation, the standing wave that had destroyed every physical prototype in 17 years of testing, smoothed. Over 3 seconds, the wild shaking resolved into a clean, sustained harmonic, low and steady, and exactly the tone the simulations had always predicted. The engine ran. 500 engineers stood in silence. The human put the hammer back in his bag. He said in the same voice he'd used to observe that the stabilizer had a mounting problem, resonance node at the lower casing joint. The housing was reinforcing the vibration instead of dampening it. It was resonating in sympathy with the standing wave and amplifying it back into the drive. Needed a physical reset. Break the standing wave pattern so the system can find its natural frequency. He paused. Same thing happens with my colony ship's water heater. Little tap, right spot, clears right up. Tessyn's entire triangular optical cluster lost alignment simultaneously. All 3 sensors pointed in slightly different directions, a condition she had not experienced since her first year of study, when her mathematics instructor had demonstrated a proof that violated her intuition so thoroughly she'd had to sit down. Her aide caught her elbow. She was not aware of needing it. She crossed the gallery floor. She didn't run. Kelvani conclave members did not run. But she moved with a directness that made the crowd part faster than it had parted for the human. She stopped in front of him. Her plating was, by this point, a mosaic she did not want to examine. Her digits were producing a harmonic her aide later described, with diplomatic understatement, as mathematically irregular. She looked at the human maintenance officer, at his grease-stained jumpsuit, at his canvas bag, at his GJP that were broad and steady and apparently capable of solving in 1 blow what 42 theoretical models had failed to explain in 17 years. She said, "What you're doing is not engineering." The human waited, in case there was more. She continued, "Engineering is theory, models, mathematical proof, verified frameworks, peer review. What you're doing is maintenance. It's useful. It is not engineering." The human said, "Okay." She said, "These problems have occupied the galaxy's finest minds for decades. You cannot simply strike them with a hammer." He said, "I just did, though." Her plating shifted in a direction that her species' medical literature had a specific entry for. She said, You don't understand the theory behind any of these systems. No, ma'am, he said, but I understand the machines. Theory tells you how something should work. I deal with how it actually works. Sometimes those are different. He reached into his bag. This, he produced the roll of duct tape, shouldn't work either, by most theoretical standards. It's adhesive on woven fabric, but it's held together ships, stations, habitats, emergency pressure seals, a jury-rigged life support coupling on the MV Perseverance in 2018-70, and one time, he paused for a fraction of a second. A man's kitchen ceiling when his water recycler failed at 3 a.m. It works because it doesn't care about theory. It just sticks. Tessyn looked at the duct tape. All 3 of her sensors converged on it. This was involuntary. She had spent 200 years training her optical cluster to parse quantum phenomena, subatomic structures, the mathematical architecture of the universe's fundamental interactions. And right now, all 3 sensors were focused on a roll of fabric adhesive tape with the intensity she'd normally reserve for a new class of particle. She was not looking at tape. She was looking at a philosophy. Good enough, right now, is better than perfect, someday. The thing that works at 3 a.m. when you have no better options and a problem that will kill you if you don't solve it. The wisdom that comes from 30 years in the maintenance tunnels of a colony ship, from never having the right tool and having to make the wrong one serve. She didn't have a Kelvani word for it. She had a theory that she didn't have a Kelvani word for it because the Kelvani had never needed to develop one. She let him return to the gallery. Station 17. The gravitational lens array. It was the showcase problem. 30 years, hundreds of researchers. The concept was fundamental. Focus gravitational waves for faster-than-light communication, cutting transit time for signals from weeks to seconds. The mathematics had been proven. The physical prototype produced a drift that accumulated over time, gradually shifting the focal point until the signal was lost. No one could find the source of the drift. It had been modeled as gravitational variance, material creep, quantum flux, atmospheric interference on various test sites, and 17 other candidate causes, each of which had been eliminated by experiment. The gallery had reached its maximum capacity. Engineers had stopped doing anything except watching. The human stood in front of the gravitational lens array for longer than he'd spent at any previous station. 5 minutes. No touching, no tapping, no flashlight. Just looking. He opened his small notebook. 30 years of maintenance observations, the handwriting dense and private, and flipped through it for 2 minutes. Then he said, "This is a calibration drift, right? The focus shifts over time?" The lead researcher confirmed. The human said, "On my ship, there's a water recycling pump that drifts off calibration every 72 hours. Exact same symptom. Built right, set right, but something pulls it off center over time. Took us about 6 months to figure out. The foundation bolts were expanding at a different rate than the housing because they were different materials, different thermal expansion coefficients. Each cycle was a fraction of a millimeter, but it accumulated." He looked at the array's mounting substrate. "What's this made of?" The lead researcher named an advanced composite. The human pointed at the mounting bolts. "And those?" "Standard fasteners, not the composite. A different alloy entirely. The standard specification, cheaper to manufacture, used on virtually every installation in the Galactic Diplomatic Corps procurement catalog." The researcher's face changed. The Cathari contingent's clicking went silent. 500 engineers, in the space of 2 seconds, performed the same calculation and arrived at the same conclusion. Different thermal expansion coefficients. Repeated cycles. Microscopic differential motion. Accumulated drift. 30 years. Hundreds of researchers. Mismatched bolts. The human reached into his bag and produced a handful of zip ties. "These won't fix it permanently," he said, "but they'll constrain the differential motion enough for a demonstration. Replace those bolts with matched fasteners." He indicated the composite substrate. "Something with the same expansion rate as the mounting surface, and your drift should stop. These'll hold it long enough to verify the concept." The lead researcher was trembling, not in distress, in the way of someone whose hands are making very small movements because their nervous system can't decide whether to laugh or cry. She accepted the zip ties. She also, in less than 4 minutes, located matched fasteners from the symposium's fabrication supplies and replaced the bolts. The gravitational lens array activated. The focal point held. 1 minute. 5, 15, 30. No drift. The alignment indicator, which in 30 years of testing had never stayed green past 8 minutes, remained green. The gallery was silent for 15 seconds. Then Goran the Growlak started laughing. It was not a quiet laugh. It shook the decorative fixtures and startled 3 species who hadn't known the Growlak had a laughter frequency. Then a Cathari team produced a rapid-fire clicking cascade that the translator rendered as incredulous amusement. Then a sound moved through 500 engineers that was not any single reaction. It was relief and outrage and joy and the particular humiliation of excellence. The feeling of being shown something obvious you should have seen yourself. The human stood in the middle of it, mildly surprised by the noise. He looked at his notebook, then at the array, and made a small note in handwriting no one else could read. Tessyn was at the railing. Her plating had reached a configuration she could feel in her second and third arms, the kind of misalignment that happened when her theoretical architecture and her observed reality stopped communicating. She had flinched 17 times. She had held a railing for the last 4 hours. She had watched a maintenance officer from a 53-year-old spacefaring species solve 11 of her gallery's 17 problems with a canvas bag of tools that included a centuries-old lubricant and a piece of tape. She was not angry. She had passed through anger around Problem 8. She was standing at the edge of something she didn't have a Kelvani word for either. The place you reach when you've spent 200 years perfecting a lens, and someone shows you that you've been looking through the wrong end. She had work to do. The closing ceremony was held the following morning. Tessyn took the stage. Her plating was not in its old configuration. She had spent the night in her quarters, and her plating had spent the night deciding what shape it wanted to settle into now. The result was not her old perfect symmetry. It was something slightly different, angled differently, the plates distributing their harmonic along a new geometry. She had examined it for a long time in her reflection surface. It didn't look wrong. It looked like a correction. She addressed the symposium. She told them that the Unsolved Problems Gallery had been designed to showcase the limits of galactic engineering knowledge. She said that the limits it had showcased were not the ones she'd intended. She said that a human maintenance officer, using a canvas bag of hand tools, had solved 11 of the gallery's 17 problems in a single day, and that several of the solutions had involved adhesive tape. She paused. She said, The solutions were not elegant. They were not theoretically sophisticated. Some of them involved striking sensitive equipment with a blunt object. But they worked. She paused again. We spent decades asking why these problems exist. The human asked a different question. He asked, what is stopping this machine from working? And then he removed the obstacle. We were engineering from theory down. He was engineering from the machine up. A longer pause. Both approaches are valid. We had simply forgotten that one of them existed. She invited Hank Patterson to the stage. He walked up the way he walked everywhere, unhurried, big hands relaxed, canvas bag over one shoulder, and he looked at the 500 engineers watching him with an expression that combined genuine gratitude with the faint discomfort of a man who'd rather be back in the maintenance tunnels. Tessyn presented him with the Grand Architect's Recognition, the symposium's highest honor, awarded once per decade to the individual who most advances the field of engineering. It was a crystal structure, precisely faceted, refracting light in ways that demonstrated 17 mathematical principles simultaneously. The human looked at it for a moment. He said, "This is real nice. Thank you." He looked out at the 500 assembled engineers of the galaxy. "Does anyone know if the cafeteria is still open?" The laughter took a long time to settle. Tessyn's plating, in its new configuration, vibrated at a frequency her aide recognized as something between amusement and peace. It was the first symposium in recorded history to end with laughter. Tessyn decided she preferred it. The MV Perseverance docked at its home station 4 days later. Hank Patterson walked off the shuttle with his canvas bag, the Grand Architect's Recognition trophy wrapped in a cloth in his bag, and a maintenance backlog that had accumulated during his absence. He placed the trophy on his workshop shelf, between a spare water pump gasket and a half-empty roll of duct tape. It looked, he decided, exactly right there. His crew asked about the symposium. He said, "Nice folks, fancy machines. They don't check their bolts often enough." He picked up his maintenance schedule and went back to work. 3 days later, a package arrived. Kelvani origin markings. Inside, a set of precision tools he didn't have names for, machined to tolerances that made his existing instruments look rough-cast. Also a note: for the machines you can't reach with a hammer, though I suspect you will try the hammer first. Tessyn. He turned the tools over in his hands, running his thumbs along the machined surfaces. He'd never held instruments this precise. He could feel the difference. Under the tools was a second package, a roll of Kelvani manufactured adhesive tape, the specifications printed on a card in trade script. Molecular level bonding. Effective range, absolute 0 to plasma state temperatures. Structural integrity rating, 10,000 years. It was, by every technical measure, the most advanced duct tape in the universe. It was also, he noted by unrolling an edge and testing it against his thumb, slightly less tacky than old reliable. The roll in his bag that had been with him for 15 years, mended, remended, partially used and partially preserved, carrying the combined memory of every emergency fix it had ever served. He kept both. He put the Kelvani tape in his bag next to the old roll. Some things didn't need improving. They just needed company. He went back to work. Somewhere on the colony ship, a seal was failing in the secondary water processing unit. He could hear it in the pipe harmonics, a change in resonance that told him the gasket was softening. He'd need to replace it by Thursday, or the pressure drop would start affecting output. He pulled on his gloves, took his bag, and went to find it. The Grand Architect's Recognition sat on the shelf, refracting light in 17 mathematically precise ways, sharing a shelf with a gasket and a roll of tape. It looked, Tessyn would have thought, exactly like it belonged there. It looked like an answer to a question the galaxy had been asking wrong. Hank reached the pipe junction, put his hand on the fitting, felt the vibration, listened to the tone. The machine spoke to him in its own language, a frequency shift, a change in pressure, the small asymmetry of a component that was 3 days from failure. He opened his bag. He pulled out the tape, both kinds. He considered them for a moment. He started with the wrench.